Good morning, children. Welcome to chemistry class 11. See the different laws of chemical combination, scientific representation of the result, significant number, accuracy, precision, and also the numericals related to mole concept and molecular empirical formula. Today we will do the stoichiometry and chemical calculations. Now the first new thing what we have to know, that is the limiting reagent. When do we say that the condition of limiting reagent would prevail and when we will not have that limiting reagent? Now here I have given the most simple example of carbon and oxygen gives carbon dioxide. So as we know, according to law of definite proportion, carbon and oxygen would always react in the ratio of 3:8 by mass. So in case we have taken 3 gram of carbon and 8 gram of oxygen, it's obvious that they are in appropriate ratio, then we will say there will be no limiting reagent, and of course 11 gram of carbon dioxide would be formed. This also verifies the law of conservation of mass. So that means when the reactants are always in appropriate ratio, there will be no limiting reagent. Let's see the two different cases. The first case where we have taken, here 6 gram of carbon, 8 gram of oxygen in the initial state. Though carbon is taken in little excess, but we know that if it has to form carbon dioxide, it will only take 3 gram of carbon dioxide with 8 gram of oxygen. That means, in case it has to form carbon dioxide, we have some excess of carbon, that is 3 gram of carbon would be excess. So the reaction is actually stopping not because of carbon. Here we do not have adequate oxygen to continue with rest 3 gram of oxygen. That means here the available oxygen is less than the required oxygen to continue the reaction to form carbon dioxide. Therefore, we will call oxygen as the limiting reagent. However, in this case, if we have limited supply of oxygen, since carbon also forms another oxide, there is every chance that carbon monoxide would be formed. That's why I am pointing out every time that if it goes to that particular product, carbon dioxide, then here carbon is excess and oxygen is one which stops or which limits the reaction. It means the reactant which is inadequate and for which the reaction is being stopped in spite of the availability of the other reactant, we call this as the limiting reagent. Now we'll see the second case where we have taken 3 gram of oxygen and 10 gram of 3 gram of carbon and 10 gram of oxygen. We know that again according to law of definite proportion, 3 gram of carbon would react only with 8 gram of oxygen. So even if we have excess of oxygen, so here oxygen though it is excess, but we do not have sufficient carbon to react with this excess oxygen. Then carbon actually limits the reaction, or carbon is called the limiting reagent. So this point is clear. When the reactants are in appropriate ratio, they do not have, none of them will be limiting reagent, but when one is excess, then this will be, the other one will be limiting reagent because the other one is not available, inadequate, and therefore stops or limits the reaction. Now coming to the next one, that is in stoichiometric calculation, we often observe mass calculation or mass volume calculation also. So what earlier we have done in mass calculation or mass volume calculation, that is we have taken a balanced chemical equation and concerned what informations we are getting from the balanced chemical equation. After that we will see how to proceed with mass calculation or mass volume calculation and what is the role of limiting reagent over here. Now coming to this, we know that the first information we get from a balanced chemical equation is the number of moles of reactant and product. So here we could say that 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to form 1 mole of calcium chloride, 1 mole of water and 1 mole of carbon dioxide. The second one, what we get, that the mass, that is 100 gram of calcium carbonate, the gram molecular mass, is reacting with 73 2 into 36.5, that is 73 gram of hydrochloric acid to form 111 gram of calcium chloride, 18 gram of water and 44 gram of carbon dioxide. It also tells that at STP, since it is 1 mole, the molar volume is 22.4 liters. So at STP, 100 gram of calcium carbonate with this much HCl or even with excess HCl is able to form 22.4 liter carbon dioxide at STP. This is the mass volume calculation. Now, if the question is, if suppose we have 50 gram of calcium carbonate and excess HCl, what will be the amount of calcium chloride in gram, water in gram, and what would be the amount of carbon dioxide in gram or the volume of carbon dioxide at STP? It's easy to answer that if 100 gram or 1 mole gives 111 gram, 50 gram will give 111 by 2. Of course, this will be 18 by 2, this will be 44 by 2 and at STP the molar volume will also be 11.2 liter. This condition will prevail only if we have excess of HCl, then the whole calcium carbonate would be utilized. That is, here nothing is limiting reagent, or at least we have 36.5 gram of HCl. In case we have any shortage of calcium carbonate, then calcium carbonate is actually the limiting reagent. That means even if we have excess HCl, but if we have instead of this 50 gram, we have 25 gram, then though at least this much HCl is present, but it is not able to continue the reaction because there is inadequacy of calcium carbonate. So here calcium carbonate would be treated as the limiting reagent. So we always have to start the reaction in respect to limiting reagent. What is the amount of limiting reagent? Accordingly, we have to take this as the known one. The other one we have to calculate accordingly. In case we have less amount of hydrochloric acid here, then HCl would be limiting reagent. So we have to proceed. So what is the amount of HCl? Accordingly, its values will be calculated. Now I have given one example that 60 gram of hydrogen and 100 gram of oxygen are mixed for combustion. Identify the limiting reagent and also calculate the amount of water formed. As we know that hydrogen and oxygen combines in 1:8 ratio to form water. So in this case, 4 gram of hydrogen would react with 32 gram or 1:8 ratio is being prevailed. That means if we have 60 gram of hydrogen, it requires 60 into 8, that is 480 gram of oxygen, but we have only limited oxygen 200 gram. Since the available oxygen is less than the required oxygen, so oxygen actually limits or stops the reaction. Therefore, oxygen is the limiting reagent. So, first part is clear, that is the identification of limiting reagent. How do we identify this? Oxygen is the limiting reagent. Now, while doing the calculation, we do not consider hydrogen. What we will consider, that 1 mole of oxygen is capable of giving 2 moles of water. So, 100 gram of oxygen, not this 60 gram, because this is not the limiting reagent. So, 100 gram of oxygen, 32 gram of oxygen is able to give 36 gram of water. Therefore, 100 gram will be able to give how much water, or just convert it into moles. That is, 1 mole is capable of giving 2 moles of water. So, 100 gram of oxygen means 100 divided by 32. What is the number of moles of oxygen? Accordingly, 2 into this much water we will get. Fine. That means whenever we have to proceed for mass calculation or mass volume calculation, take the limiting reagent, if any, as the starting one or as the reference one, because it is that which reacts completely. The other species, even if it is present in excess, will remain unreacted. Thank you. In case you have any difficulty, any doubt, please do write in the comment box.